Eliese here with some edible science for you. Today we're talking about the rock cycle, and we are going to replicate the rock cycle using some chocolate chips. Now if you want to do this at home, you can use a blend of white chocolate, dark chocolate, and milk chocolate, but I lucked out and found this lovely bag of mixed pastel color chocolate chips that worked really well for it. So let's get going. So here are my chocolate chips in various colors. The life of a rock actually starts very, very hot deep inside the earth. So I melted some of my chocolate chips up, turned them into chocolate chip magma, if you will. And we're gonna follow the life of that magma as it cools into rock and then changes forms. So when we have things like volcanic eruptions that bring hot bubbling magma, hot molten rock to the surface where it cools, we create igneous rocks. So for instance, with my chocolate chips, we end up with this. My melted chocolate chips are allowed to cool. It's relatively smooth, relatively similar color throughout, much like my example of igneous rock here, obsidian. So obsidian, or volcanic glass, is very smooth, very uniform, and it's a great example of an igneous rock. This forms when lava cools very quickly on the surface. So obsidian and our chocolate chip igneous rock, you can see how those would be very similar. And that's sort of our first step on our rocks journey. Now, if over time, let's say some of our igneous rocks got broken down into little bitty bits that were maybe carried away by wind or water and piled up together somewhere else, we would get our next type of rock, a sedimentary rock. So here I have several chocolate chips that I squished together with a stack of books. I actually added just a little bit of sugar syrup to help stick them together, because in the real world, our sedimentary rocks have a little bit of help from water and minerals that help stick them together. So this sedimentary rock is very similar to this one. This is what we call conglomerate. It's a great example of a sedimentary rock because you can see the individual pieces of sediment and rock that all sort of squished together with a little bit of help from some water to create almost a concrete glue to create our sedimentary rock. You can see the individual pieces that make it up. Now, if that sedimentary rock, or even our original igneous rock, had lots of heat and lots of pressure put onto it, we would instead get our third type of rock, our metamorphic rock. So this is a rock, or a chocolate chip rock rather, that I took my chocolate chips, put them in some parchment paper, microwaved for about 10 seconds, and then squished with my hands. So I added heat and I added pressure. And the result is that the texture is pretty uniform, but you can see some of the different rocks that contributed to it. So the different minerals and things that might have made it up. So for instance, this is a metamorphic rock called gneiss, and you can see that there are a couple of different things that make it up. Uniform texture, but some different patterning based on what all is in there. To explain this another way, I have my lovely foam rock here. When you're making a metamorphic rock, that pressure can act in two different ways. It can be directional, which gives us kind of stripes like we see on our gneiss, or it can be surrounding, where it's coming from all sides. And you can see where we don't necessarily get stripes, but we would potentially be able to see the individual different types of crystals and rocks involved. So at any point in our rock cycle, rocks can jump around. So our metamorphic rock might break down into sediment and contribute to a sedimentary rock. Same with our igneous rock. Our sedimentary rock may just fall apart and become loose sediment again. Our igneous rock may undergo pressure and heat and become metamorphic. And it's even possible that any of these, if they got melted down completely and brought back up from that magma supply, could become an igneous rock. So the rock cycle has lots of different avenues, but our three main types of rock, igneous, sedimentary, and metamorphic, follow those basic rules. So now that you know some of the characteristics of the three types of rocks, check out some rocks near your home. See if you can figure out whether they might be igneous, sedimentary, or metamorphic. And in the meantime, maybe make some chocolate chip cookies. Thanks for coming by.